once the connection is made that the derivative of a function is the formula for the slope of the tangent to the function at any value in the domain of the function for which the derivative exists, and then also you've looked at a couple different examples where you found derivatives using the definition of derivative, which I've done on another video that I've linked in the description of this video, you're ready to actually look at some different rules and properties of derivatives to be able to open up your experience of differentiating other types of functions and being able to get there with things that people have identified as occurring over and over so that you can utilize that information in finding your derivatives for problems that you're asked to do. This video starts with the very basic derivative rules and properties, and then I'll make more videos that go on to looking at other properties of the differentiation process and also expanding the different functions that you can find the derivative of. So let's get started. Here it just gives some basic differentiation rules. So we're just going to start with the very beginning building blocks and then continue to go on from there. Now the notation-wise, the derivative of c with respect to x is what this is saying, is like an operator notation. You're told to do this process of find the derivative of that expression that's in the brackets. So when we want to think of what the derivative with respect to x of a constant is, this would be a constant with respect to the variable x. Well, that derivative is just 0. And if you were to think about just like our graphs of this, our y equal a number is just a horizontal line. And the slope of a horizontal line is 0. And the derivative gives me the slope of the curve at a given point. And for a horizontal line, the slope is 0 throughout the entire domain. Now, if n is a rational number, then the derivative with respect to x of x to the n power works out to be n times x to the n minus 1 exponent. And you could see that over and over occurring when you're looking at finding the derivative of x to a rational number power using the definition of the derivative. But here, since someone else has identified that is something that keeps reoccurring, we can just go ahead and use the rules that they've found for that. Now the next things are different properties of derivatives. So if I'm taking the derivative with respect to x of a number multiplied to a function, and this is a constant with respect to the letter that we're differentiating with respect to. So if we're taking the derivative of a number times a function, then you can get that by taking the number times the derivative of the function. So with constant factors, you just multiply that to whatever you get of the derivative of the function itself. The derivative with respect to x of the addition of two functions is the derivative of the first function plus the derivative of the second function. And here I'm going to go ahead and use another notation for the derivative just so that you realize that there's different notations for the derivative and we can just get more comfortable with them. So I could write d dx of f of x for the derivative notation, but another notation we've seen before is that prime notation on it. So I could write this as f prime of x plus g prime of x. And I could have even written that up here. I could have written this one as k times f prime of x when looking at that property. Now the derivative with respect to x of a function f of x subtract a function g of x, that's just the subtraction of the derivatives of the functions. So sometimes we say we can do term by term differentiation. Now notice that's the last one that I have with arithmetic operations on functions yet. When I'm taking the derivative of a multiplication of two functions or the derivative of a division of two functions, it entails a little bit more work with going out with the property that would actually work out to be the correct derivative. So I had to save that for another video. And again, that'll be linked in the description of this one as well if you need to look at the product rule or the quotient rule for differentiation. Some other functions that we're ready to find the derivative of now, just again as our basic building blocks, is that the derivative with respect to x of the sine of x is cosine of x, and the derivative with respect to x of cosine of x is equal to negative sine x. And then lastly, the derivative with respect to x of e to the x is actually e to the x. E to the x is a function that is its own derivative. At any point on the graph, y equal e to the x, it's the coolest type of thing that happens with that function. At any point on the curve, y equal e to the x, the slope of the tangent to that curve is the same as the y coordinate at the point of tangency. So with these building blocks now, we're going to do some different examples to show you how you can utilize these basic rules and properties to find the derivative of some of your introductory functions. So hopefully you've written down the basic rules and the properties that we had at the beginning of the video. Now we're going to apply those to find some derivatives. First up is f of x is equal to 5x to the third minus 2x plus 1, and it says find f prime of x. So when it asks you to find f prime of x, it's asking you to find the derivative of that function. So the first thing I look at is that it is term by term, so I can use my term by term differentiation. And also in each of the terms, I have a number times letter base to rational number exponent in these, or a number times my x to the first. So I can go ahead and just find this derivative using those basic rules. So f prime of x is equal to, and you always want to use good notation so that you can get this information to another person and they know what you started with your function, they know what you have for your derivative. So in my first term, 5 times x to the third's derivative is 5 times the derivative of x to the third. Now the derivative of x to the third power is bring down the 3, keep the base x, and subtract 1 from the exponent. But when I bring the 3 down, I multiply it to whatever numerical coefficient's in front of it. So 3 times 5 is 15, keep that base x, and 3 subtract 1 is an exponent of 2. In the next term, it's negative 2 times x to the first. Well, that'll be negative 2 times the derivative of x to the first, and the derivative of x to the first is 1, so I have negative 2 times 1, or negative 2. And then for my constant term, the derivative of a constant term is 0. So my derivative is f prime of x is equal to 15x squared minus 2. Let's look at the next one. Here, I need to rewrite my function before I actually calculate the derivative on this. And so it's still the original function, so I'm still going to call it f of x, but I need to rewrite it so that I can use my basic rules of derivatives. Here, I have 3 times the 4th root of x, and I don't have a way of really looking at the derivative when the radical notation is there. But I want to remember that a radical notation has a fractional exponent counterpart. The fractional exponent that means the same thing as the radical notation will have whatever under the radical as the base, and then the exponent has the fraction where the numerator is the power and the denominator is the index of the radical. So this is 3 times x to the 1/4 power, and then plus sine x. And you don't want to like start differentiating part of it and rewriting other part of it, or you really get confused on where you're at. Rewrite all in one line and then differentiate all in one line. So here now I'm going to do the derivative. So I'm going to show that by saying f prime of x is equal to, this is number times letter base to a rational power exponent. So I'm going to bring this rational power exponent down and multiply it to the number that's in front. So 3 over 1 times 1 over 4 is what we're going to have for that. So that's 3/4 x to the, and now think, 1/4 subtract 1. Well, that's 1/4 subtract 4/4, which is a negative 3/4. Now, also then, the derivative of sine x is cosine x. So I differentiated everything in the same stage. And then if you look at what the requirements are for how you're supposed to write your answer, make sure you follow whatever is required of you to write your simplification. Some will have it where you want to write it without negative exponent, so you could write f prime of x is equal to 3 over 4 times x to the positive 3/4, and then plus the cosine of x. But again, that you would want to see what the person that you are reporting to would want you to do in terms of rewriting it. Or if you need to go back to the radical notation, or also if you go back to the radical notation, if they would want you to rationalize it. Let's look at the next one. So here I'm going to have to rewrite that second term. So this is still the function f of x, so I still call it f of x. And I'm actually going to have to rewrite this first term, because back in those rules of exponents, I needed it as letter base to rational exponent, and this has a fraction with the letter in the bottom. We don't know how to differentiate that with a rule yet. It's not in our library of things that we know how to work with at this point. So I need to rewrite this 1 over x to the third to the same equivalent expression with different notation that means this. And remember, if I have my x to the negative 3 exponent, that means the same thing as 1 over x to the third. And then plus the cubed root of x to the fifth is x to the fractional exponent. The index is the denominator of the exponent, and the power is the numerator of the exponent. And then I have minus 4. So now we've rewritten it, we're ready to differentiate it. F prime of x is letter base to rational exponent, bring down the exponent, keep the base, subtract 1 from it. Be careful, we have mindsets that go haywire sometimes with this. What's negative 3 subtract 1? Well, negative 3 subtract 1 is negative 4. And then plus, letter base to rational number exponent, I bring down the exponent 5/3, keep the base of x, subtract 1 from the exponent. What is 5/3 subtract 1? Well, 5/3 subtract 1 is 5/3 subtract 3/3, which is 2/3. And then the derivative of a constant term is 0. So our derivative f prime of x is, remember, this is multiplied, and so the exponent of negative 4 only reaches the x unless it has help from parentheses. So this first term written without a negative exponent will be negative 3 over x to the 4th. And then plus, and I can write this next term as 5/3 times the denominator of the fractional exponents, your index, so that's cube root, and the numerator is the power on the x, so x squared. Okay, how about D? Here again we need to rewrite this first, so we're going to rewrite it as f of x is equal to 3e to the x is fine, but I can't differentiate it with the rules that we have so far with the letter in the denominator of the exponent. It is attached by multiplication. So to rewrite plus 7 over 4x squared, it's going to be 7/4 x to the negative 2. Now that we've rewritten it, we're ready to differentiate it. F prime of x is equal to, well, a constant times a function's derivative is the constant times the derivative of the function. But the derivative of e to the x is e to the x. It's that function who is its own derivative. So 3 times the derivative of e to the x is still 3e to the x. I did differentiate it, it's just that that function is its own derivative. And then next up, we're going to differentiate this last term. We're going to bring down the exponent and multiply it to the 7/4. Well, negative 2 multiplied to positive 7/4. Negative times positive is negative. And the 2 times the 7/4 will be 14/4, which simplifies to 7/2. X to the, and then that becomes negative 2 subtract 1 is negative 3. So my derivative here, f prime of x, is equal to 3e to the x minus 7 over 2x cubed when I write it without my negative exponents. Let's do some more examples. So here are some examples where you have to do a little bit more rewriting than the ones we had in the previous set that we did before you can differentiate. And again, it's because we are just starting with the beginning properties that we need to do some of this rewriting. As you get more properties and more rules of differentiation under your belt, there will be alternate ways of going and finding some of these derivatives. We'll still get the same derivative, just from a different path, and after simplification we would be able to notice it. So let's see what we have. So here f of x is equal to x squared times 2x minus 1. Now so far with all we have is our ammunition is our derivative of a constant is 0, the derivative of x to the first is just 1, the derivative of x to the n, where n is a rational number, is n times x to the n minus 1. The derivative of cosine of x is negative sine x. The derivative of sine x is cosine x. The derivative of e to the x is e to the x. And we had the derivative of a constant times a function is the constant times the derivative of the function. The derivative of the sum of two functions is the sum of the derivatives of those two functions. And then the derivative of a difference of two functions is the difference of the derivative of those functions. But we haven't gotten to the point where we've learned about the derivative of a multiplication of two functions, nor the derivative of a division of two functions. It's later on. And I have linked that video into this description if that's the type of problem you're searching to get information about. But right now, our hands are tied with what we did at the beginning of this video. So I can't take the derivative of this function the way it's written at this point in the game unless I rewrite it first and then try to see if my rules apply. Now, when I see that it's a multiplication of a variable expression to a variable expression, and then I see that this is just to the first power, my rewriting on this first one for the function is just to distribute the x squared, so that'll be 2x cubed, and then minus x squared. And now I've written it as separate terms, and I can differentiate over a subtraction or an addition of functions. So now I'm ready to take the derivative, and the derivative of the first term, 2 times x to the third, bring the 3 down, multiply to 2, that gives me 6x to the, subtract 1 from the exponent, 3 subtract 1 is 2. And then minus, letter base to number power, bring down the exponent, write the base x, subtract 1 from 2 is just an exponent of 1. I'll write it there to start with. but in simplified form, we don't write down the exponent of 1. It's assumed when you see that factor of your variable. And again, what this derivative does is at any given x value in the domain of the original function where the derivative exists, if you put the x through the derivative, it gives you the slope of the tangent line to the original function at that x value, which is also defined to be the slope of the curve there. Let's do the next one. Well, in the next one, I have several different terms in the numerator divided by, and there's a letter in the denominator. We're not to the point where we have a rule for a function divided by a function yet. Again, if you want to see what the rule is and to practice some of those, it's linked in the description of this video. But we don't have it yet as far as how we're developing the process. So what I have to do is rewrite this before I differentiate it. Now, when it has a one-term denominator and several terms in the numerator, rewriting it is you can rewrite it as each term in the numerator over that common denominator. So I can write this as 4x squared over x to the 4th plus 2x over x to the 4th minus 1 over x to the 4th. Because remember, with fractions, when you have common denominators and you're adding or subtracting, then you do the addition or subtraction over the numerator and keep the common denominator. Well, if I have it where it already has the common denominator, I can break it back up when that process suits what I need to do. And that's here. Because now, in this function, and I'm not differentiating yet, I'm just simplifying at this point, I can simplify then each of these fractions individually, so then I can get ready to then do the differentiation process. Well, the simplification of 4x squared over x to the 4th, you have a common factor of x squared that would remove. You'd end up with 4 over x squared, but I need to rewrite 4 over x squared as 4 times x to the negative 2 power to get ready to differentiate it. So this is 4 times x to the negative 2 power. Then plus 2x over x to the 4th simplifies to 2 over x to the 3rd. But again, I want to get ready to differentiate it, so I want to write that as 2 times x to the negative 3 power. And minus 1 over x to the 4th, I need to write out as x to the negative 4 power. And now we have term by term. We have constant times, or just variable to the rational exponent. Now we are ready to differentiate. And first term, that'll give me a negative 8. X to the negative 2 subtract 1 is negative 3 power. And then negative 3 times positive 2 is a negative 6. X to the negative 3 minus 1 is negative 4 power. And then negative 4 times negative 1, think of that in the front. So negative 4 times negative 1 is a plus 4. X to the negative 4 minus 1 is negative 5 power. And then certainly you could rewrite it in a final form of f prime of x equals negative 8 over x to the 3rd minus 6 over x to the 4 plus 4 over x to the 5th, if you would like to do that in your final form. Let's look at the next one. In the next one, I have a constant 3 times this binomial that's squared. So I can't do the derivative basic rules we know so far on this expression the way it's sitting. I have to rewrite it first to get it as term-by-term derivatives of just those bare bones ones we've learned. So our function f of x, keep the 3, that can't be multiplied through until after you multiply out the 4x minus 3 times 4x minus 3. Now if you go through and multiply that out, the 4x minus 3 times 4x minus 3 is 16x squared minus 12x minus 12x, and then negative times negative is a plus 9. So this multiplication is 16x squared minus 24x, and then plus 9. Still need to multiply through with the 3, so I'm still rewriting. I'm not differentiating yet. So f of x is 48x squared minus 72x, and then plus 27. And now that I have it term by term, and I have it as letter-based to number power, or the trig functions that we have, I can go ahead and do the derivative. F prime of x is equal to, well, 48 times x squared's derivative is 2 times 48, so 96x to the subtract 1 from the exponent, that'll just be an x to the first. Then the derivative of negative 72x is negative 72, because the derivative of x is just 1. And then the derivative of a constant term is 0. So this is my derivative, and I don't need to write that exponent of 1. Our derivative of this original function is 96x minus 72. And then lastly, for our function f of x here, I need to rewrite it again before I can take the derivative. And I actually need to figure out what I'm doing for the rewriting. So this 1 over quantity 3x squared to the third power, that's 1 over, remember if it's a multiplication, you would take each factor to that power. So 3 to the third is 27, and x squared to the third is x to the sixth. And again, don't do partial simplification and the other part derivative. You're going to get all messed up. Get everything simplified and then differentiate all in one stage. Now I still need to simplify a little bit longer, a little bit more. So think about this 1 over 27x to the sixth. I have to write it as a number times my x to a power so that my x isn't in the denominator. So bringing this up would be times an x to the negative 6. So that's 1 over 27 times x to the negative 6th power, and then plus 4 times the cosine of x. Now it's ready to differentiate. So now's the time I need to put that f prime of x notation in there. And then bring the exponent down, multiply to the constant in front. So negative 6 times 1 over 27 is negative 6 over 27. And I know that simplifies. We're going to come back and do that real quick afterwards. So x to the subtract 1 from the exponent, negative 6 minus 1 is negative 7. And then plus the derivative of cosine x is negative sine x. So 4 times negative sine x is negative 4 sine x. So I jumped the gun on that. So negative 4 sine x. And again, the derivative of 4 times cosine x is 4 times negative sine x, which would be negative 4 sine x. And then lastly, if I were writing it simplified and without negative exponents, f prime of x would be common factor of 3 top and bottom is negative 2/9. And then that x to the negative 7 becomes an x to the positive 7 in the denominator, and then minus my 4 sine x. So hopefully you can see this bottom one there. This is actually our derivative. We just needed to simplify this to take out the common factor of 3. So I wrote negative 2 over 9. And then I wrote that x to the negative 7 as an x to the 7 in the denominator. So hopefully that gives you several different examples of how to find the. So here we're going to look at, again, just getting some more practice of finding the derivative, but then also what do they mean when they're asking us to find the derivative at a given value. Our function for this example is 3x to the 4th minus 5x squared plus 7. So I look at this and there's separate terms. There's no letters in the denominator of a fraction. There's no multiplication of letter expressions. So this is ready to differentiate the way it is. And this first one just says to find f prime of x, so the same variable that the function is acting on. So here I'm just going to straight differentiate it, and this first term's derivative is going to be 12x cubed, and then minus 10x, and then our constant term's derivative is 0. So that's the part A. Now the next part is to look at the derivative evaluated at a specific x value. So here it's just asking me to put 0 in for all the x's in the derivative of the function. I already found the derivative, so I'm just going to go 12 times take out the x, put in 0 and cube it, minus 10 times take out the x and put in 0. So specifically here, our f prime of 0, don't write f prime of x, because f prime of x is this expression. F prime of 0 is what we just calculated, and it works out to be 0. Next one is find f prime of negative 2. So I go to the derivative. Your notation tells you which one you're supposed to go to, and then here take out the x's and put in negative 2. So this is going to be 12 times negative 2 quantity cubed minus 10 times negative 2. So my f prime of negative 2 is equal to, look at your exponents first, so that's 12 times, negative 2 cubed is negative 8, and then negative 10 times negative 2 is plus 20. So I get my f prime of negative 2 is equal to negative 96 plus 20. Our f prime of negative 2 is equal to negative 76. So watch your notation. Make sure that you're starting to get good habits about how you write your own notation as well. And it'll keep you a little bit more organized to be able to keep your thoughts straight and be able to be successful in finding your derivatives.